Hello, Calculus, BC. Alright, this is number 8 on the worksheet. Now there's a mistake on it, so I kind of want to go over some things real quickly on this one. I noticed changed a couple things when I fixed the first sentence, and then I put down, and the second question is how fast is the distance between the observer and the rocket changing at that moment. So let's go ahead and answer this question with you. Now the first question really isn't a calculus problem, more of a pre-cal problem. We're looking for how high the rocket went. So I'm going to write down my givens. I'm always going to write down my givens. I'm given the angle, theta, is 5 pi over 11, and I'm also given the change of the angle, d theta dt, is 0.1 radians per second, which is actually pretty quick. That's about 6 degrees a second. That's actually going very fast, but I made up this problem. So the answer may not make total sense, but it's okay. I made it up. So I draw my picture here. We have the observer. There she is. She observes a rocket from 16 kilometers away. So we'll call that A. We're looking to find the length B. So we want to find B. Now notice, write out my given, what I'm trying to find. Okay, we're always trying to write out what we're given and what we're trying to find here. So make sure you do that, okay? Not D, B. So I'm going to use a trig function because they give me this angle theta here. And it's easy. We're going to use the tangent of the angle B over A. So we know the angle, tangent of 5 pi over 11 equals B over 16. So we can get B very easily. And if I use my calculator here, clear everything out there, I take the tangent, 5 pi divided by 11, and I'm going to multiply that by 16. And we get 111.282 kilometers. So probably at that distance, you really can't see the rocket. But, you know, like I said, this was a made-up problem. And when all else fails, what did Einstein say? Trust your math. I'm also going to get this distance right here. And I'm just going to use the Pythagorean theorem. I might need it. So that's easy. 16 squared plus 111.282 squared. And I take the square root of that answer. And that gives me 112.426 kilometers. So that's how far the observer is from the rocket at that moment. Because there's a rocket, little tiny speck at that distance. Now the next question involves calculus. How fast is the distance changing? So what they're looking for here, we got C. We want to find dc dt. Again, I wrote out what I'm trying to find. I wrote out what I'm trying to find. So once I write out what it is I'm trying to find right now I can set up my picture again. I can find out well, looking for dc dt. Well, I know A is a constant, so I think, well, which trig function can I use? I'm looking for the change in C. I know that's a constant. I'm looking at cosine. Cosine of my angle is A over C because that's my constant. So this becomes cosine of theta equals 16 over C. So now when I take my derivative, negative sine theta, d theta dt, be careful taking the derivative here, negative 16 over C squared, dc dt. And there's my derivative. I just plug in everything now. We know a lot of this already. We know this angle is 5 pi over 11. d theta dt we know is 0.1. And we know this becomes negative 16, and we found C earlier as 112.426 squared dc dt. So what I'm going to do, I'm just going to go and solve for dc dt. I pretend like I don't have a calculator. Negative sine, actually the two negatives are going to cancel, so I don't even have to worry about that. Sine of 5 pi over 11 times 0.1. I'm going to multiply that by 112.426 squared, and then divide all of that by 16. And this is going to give me my change in C. And if I type it in, now you're going to get a big number here, but again, the math is all correct. That's all we're really worried about right now. So we get the sine of 5 pi divided by 11, whoop, not 44, 11, times 0.1, and I'm going to times that by 112.426 squared. Hit enter, and I divide that by 16. And we get 78.193 kilometers per second. Yes, that's super fast. This is how Mr. Werner rides. Okay? That's super fast. But you're talking about 0.1 radians a second. That's not really realistic at that height, how fast the rocket would be changing in terms of the angle. So Try this, and I'll see you guys tomorrow. Bye.